Hi everyone, I'm just going to do a little short video on all the definitions that we have to learn in relation to water. So first of all, let's have a look at some little pictures. We learnt all about texture in our early lessons. This one is sand, so very large rock particles, so therefore the pore spaces which can fill with water are called macropores. These are the largest pores. Our next type of soil texture was silt, which are medium-sized rock particles, and we can name the pore spaces between these slightly smaller than a macropore. These are called mesopores. These are medium-sized pore spaces which can fill with water. Then our smallest rock particles are our clay particles, which have very tiny pore spaces which can fill with water, and these are called micropores. These are really small. So most soils, in the UK anyway, will be made up of a mixture of sand, silt and clay. And so there will be a mixture of macropores, mesopores and micropores. And there will also be a little bit of organic, well, it might be a lot of organic matter. There'll be some organic matter in there as well, which will also contribute to different sizes of pore spaces. So if you have a very clay soil or a very sandy soil, adding organic matter will improve the variety of the sizes of pore spaces. So this is what we call a loam soil, when we have a mixture of sand, silt and clay in fairly even proportions. But most soils anyway will have all three in. So those are our different pore sizes: micro, meso and macro pore spaces. So first of all, let's consider something called saturation point in a soil. So these terms have been devised so that soils can be assessed for their own, each for their own merits, and there needed to be some way of measuring water, assessing water. So that's what these terms were designed for. So if we first of all look at saturation point. So here I have a little wallflower cutting, which I've got going in my propagator here behind, with some bottom heat. The greenhouse isn't heated, but that is, and it just keeps them ticking over, a bit of warm heat at the bottom for roots, and the top cooler. So this one is growing really well. This one here is not so much. This has reached its permanent wilting point, I think, which we'll talk about later. But if we have a look at this one, it's growing really, really well. The soil feels slightly damp, or the compost feels slightly damp, so it does have some water in it, but it also has some air spaces in it. I know that because it's growing really well and there's no diseases. You know, you wouldn't get good root systems and good top growth if there was no oxygen or air in that growing medium. So I have a plant. If I was to, or were to, water this now from the top, so this could be rain outside. We call it sort of outside in the garden, in the field. This is obviously in a container for demonstration purposes. But in the field, we could have lots of rain, or we could have a rotating sprinkler system perhaps, watering things from above in the vegetable garden, say. So we're watering it from the top. I'm also going to water it from the bottom as well. And if we were to let this sit for a while, the pore spaces would get filled from the top, and also the water would rise up through the tiny pore spaces by capillarity, a little bit like how water travels up stems in that continuous column. All the pores join together to form these sort of little straws, wiggly straws if you like. So water will rise by capillarity and infiltrate downwards. And if I were to leave this for an hour or so, we would call this growing medium saturated. Okay, so that would mean that every pore space is full of water. The macro, meso and micropores are all full of water. So if we were to define saturation point, it is defined as the amount of water in the soil when all the pore spaces are full of water. Okay, so that is our saturation point. Now, if I were to remove this and allow it to drain freely, you can see that it would be dripping. Now, this would happen in the field as well, provided that there's nothing to impede drainage. You know, the water would infiltrate further downwards into the subsoil and lower down. And at a certain point, see, this is still dripping. Come on, have a drip. Yeah. At a certain point, depending on my soil type, that dripping would stop. And at that point, all the macropores, the large pores, would be empty because the water's dripped out of them. But the mesopores and the micropores would be full of water. So we've got a really good combination. We've got air in the macropores and we've got water in the mesopores and the micropores. So we could call that free draining but moisture retentive. Whether it's in the field or whether it's in a container, it's free draining but moisture retentive. And that's what is ideal for most plant growth. It's ideal. Oxygen and water. So this is what we call field capacity. This is what growers will aim for. It's the Goldilocks of drainage, if you like. It's free draining but moisture retentive. Field capacity is defined as the amount of water in the soil after it has been saturated and then allowed to drain freely. We could also define it as the amount of water in the soil, in the mesopores and micropores after it has been saturated and allowed to drain freely. Okay, so that's field capacity. That's what, as a grower, you are aiming for. And now we go on to my poorly looking specimen here, which is the same plant. Well, there's two cuttings in that one actually. So this plant, I think, has reached what we call permanent wilting point. So permanent wilting point is defined as the amount of water in the soil, in the field or in a container that can be measured when a plant wilts but does not recover after watering. So I don't think this will recover, but I won't know until I try to water it, which I'm going to do after this. So I'm going to just presume that this is at its permanent wilting point. So it's the amount of water in this growing medium at this point is called the permanent wilting point. When a plant is at its permanent wilting point, it's dead, obviously, or it's not going to recover, it will die. The water is measured in the micropores only in this case, because the macropores were empty anyway after it had drained. We'd reached our field capacity. The mesopores had water in, but that's been absorbed by the roots because the roots can take the water out of the mesopores. But there will still be some water left in the micropores because although it's there, it's not available to the plant roots. They can't actually release the water from that sort of cohesion stickiness that water has. You know, it will stick to the insides of those tiny pores and the roots just don't have the force to draw it upwards. So at permanent wilting point, it is a measure of water left in the soil when a plant has wilted, but then does not recover when watered. That's permanent wilting point. So if we were to summarise what we've just done, those three key terms. Saturation point is where all 3 pore sizes are full of water: macro, meso and micropores. Obviously in a clay soil there's a lot more of these, and in a sandy soil there's a lot more of these. Okay, so that's saturation point. Permanent wilting point is when there's hardly any water, the plant doesn't recover, but there will still be a little bit of water to be measured in those micropores, which is not available to the plant. Field capacity is your kind of Goldilocks of water retention. Your macropores have drained and they'll be full of oxygen for healthy root growth and respiration. And there's water in the mesopores, which can be easily taken up by the roots, and there will be still water in those micropores, which will not be available. Obviously in most soils it's not as simple as these just 3 types of pore space. There's going to be lots of in-between sizes, but this is just a really kind of simplified way of understanding it and helping to understand those different soil terms, which can be quite difficult to understand. So I hope that makes that a little bit easier. The definitions are in the notes. There's a few more definitions, such as available water, but I think it probably makes sense now if you understand what we've explained in the video. So hope that helps. I'm going to sign off for now.